All right, we're going to start with lesson N8.1, which is squares and square roots. The first thing we need to know is what is a perfect square and the definition. So what that means is a product of whole numbers multiplied by itself. Product, remember back that that's the answer to a multiplication question. And we use 49 here, is a perfect square because 7 times 7 is 49. So you're going to hear a number multiplied by itself in here once in a while, or you're going to read about it, and that's exactly what that means. 7 times 7 equals 49. 49 is a perfect square. And perfect squares can also be called square numbers. All right, so 49 is a square number because a number times itself equals it. So let's use the number 36. This is another way to find if it's a perfect square or not, is by doing factoring. So I want this in ascending order, which means from smallest to greatest. And here we go. I'm going to 1, 36. I don't know how many are going to be in between, so I'm separating them pretty far here. I know 2 times 18 is 36. I know 3 times 12. And 4 times 9. And then 6 is the last one, and times itself, 6 is 36. So I only write this once. You don't write numbers that are the same twice. Okay, so here are my factors. And I now know that this is a perfect square because in the middle it ended up with a number times itself. And there's 4 on this side and 4 on this side. I could even list all the factors and count all these up and just find my middle number. But this is proof that 6 times 6 is 36, making 36 a perfect square. Now, this also tells you what the square root of a number is too, but we'll talk a little bit about that later. Later as in now. All right, so the definition of a square root. So it's a number, there's the value of that, when multiplied by itself gives the number, which kind of is weird wording, so let's look at it. So a number multiplied by itself gives you this. You know this is a square number from the previous page. So the actual square root is this 4. So a number is a value that when multiplied by itself gives you this answer. So the square root symbol looks like this. 16 would be in here if we're saying find the square root of 16. And here's our number value, 4. All right, so now I know 16 is a square number. We know the square root of 16 is 4 because it's a number times itself. Factor trees are another way to find square roots because you can break them down into prime numbers. This is just a summary, kind of a replay of what you would have maybe covered last year. This factor tree is broken down. 6 times 4, they took 24. I don't usually circle the factors until they're actually prime numbers. And then it broke down to 3 times 2 times 2. All right, and again in ascending order. So put them from smallest to greatest. 2 times 2 times 2 times 3. And no matter how you break up a number, it's always going to end up the same. So 56 can be 28 times 2, or it can be 8 times 7. Regardless, when you break down those factors into prime factors, you're going to yield the same numbers. All right, so if you took 2 times 2 times 2 times 7, you would get 56. Now I'll show you this because you can also use prime factoration factor trees to find square roots. So I'm going to just review real quick here a factor tree, 9 times 2, and what I mean by only circling the numbers that are prime factors. So 2, rewrite in ascending order. All right, there's my product of prime factors. Here we have 8 times 3, 4 times 2. So these might not be in order, but when you're done, we'll put them in order. And again, circle them when they're finished because sometimes they get lost in the tree. So 2 times 2 times 2 times 3 is 24. All right, this is where I'm talking about square root. So 324 is a big number. I have no idea how to break it down really quickly. So I'm going to actually start with 2. There's probably a bigger, or there's obviously, pardon me, a bigger number that we could break this into, but I'm going with 2 because I know my rules of divisibility ends in an even number. I know 2 goes into it. And I'm going to do that again. 2 times 81. This is done. And now I'm trucking. 9 times 9 will be 3 times 3. And those are all finished. All right, so now when I write all these out, oops, sorry, a little touchy here, I'll get 2 times 2 times 3 times 3 times 3 times 3. And I am going to look at this and notice that I have the same amount of 2's and 3's. All right, so I guess not the same amount. I can pair them. That's a better way to put it. So I'm going to pair them up like this. All right, and then I'm going to write them with 1 in each pair. One from each pair. Right now I already know that this is actually a square root because I can actually do that. Now to actually find the square root, like what that number is of 324, I'm going to go 3 times 3 is 9 times 2 is 18. And I got 18 times 18. So this tells me that the square root of 324 is 18. If I were to break this down into a factor tree and I ended up with numbers like this, where there isn't the same amount, or you can't pair them off or triple them off, then I know that these are definitely not numbers that have a square root. And the numbers themselves aren't perfect squares. Right? So we know that 324 is a perfect square because 18 times 18 equals 324. And the other way to say it is the square root of 324 is 18. All right, and again, we'll replay that into just simple words instead of all my scribbles. So square root is one of 2 equal factors of a number. 81 we'll use. Square root of 81 is 9 because 9 times 9, or 9 squared, we're going to use that exponential notation. Or it can be shown as the square root of 81 is 9. But again, your key numbers here. And a picture, way to look at it, is actually drawing the square. So when we say square root, we're actually talking about a square. So we've got 4 by 4 here. The factors are 4 and 4. The product or multiplication question, 4 times 4 is 16, the answer. And again, we'll write it like this now. 4 squared equals 16. Instead of writing it like this, let's get into exponential notation. And again, can show the square root of 16 equals 4. And of course, this makes a perfect square because the sides are the same. All right, a quick little practice here. Simple 3 by 3 square. All right, 3 squared means 3 by 3. Again, we're going to get used to writing like that. Saves writing and is more mathematical. And this is what it's going to look like if we're doing that, okay? As opposed to, we're going to try to get away from this. Okay, quick activity here of finding the perfect squares. So here's that exponential notation. 13 squared, I'll just do these real quick and give them away, is 169, so 13 times 13. 15 squared, 15 times itself, is 225. 20 squared will be 400, and 100 squared is going to be 10,000. And let's go the other way. Square root of 81, number times itself, equals 81, is 9. 121 is 11. Hopefully these will be just come to you as we get going through this unit. This is 6, and of course 400 will be 20. And if we put it all together here, right, 3 squared, written like this, is 9. and the square root of 9 is 3. So this is exactly what we want it to look like, right? With this being kind of our end game if we're asked what the squares of a number or the square root. And then we can actually get to squares. So let's think of something practical in our society where you'll use this, because you know I can hear you saying, I'm never going to use this. All right, this is your room. It's nice and square. You need new carpet. You have to measure the side. And you find out it's 14, we'll say feet. And in order to find the area of the square, we have to take 14 times itself, right? We'll get 196, and I said feet, so this one didn't give you feet. So they have square units as an answer. So if you were working on that carpet, you go into the store and you'd say, I need 196 square units of carpet, and that would fill your space. Now, area, remember, when you hear area, we often hear length times width. In a square, it's side times side. So area would equal side squared. And then the length of the side, we have to find that. So you know that you have an area of 256 for your square, whatever it might be, and you need to know what the sides are. Let's say this is your yard, okay, and you're building a fence. You need to know the sides, the dimensions. So when you go into the hardware store, you can tell them. And the square root of 256 is, actually, this is a good one where I don't exactly, might not know it off the top of my head. So I'm going to take it in and do a factor tree. I'll be asking you to show your work, so don't think that you can just punch the square root sign on a calculator. You can use that maybe later when we're actually doing estimates. Okay, so let's do a factor tree. 256. 2 times 128. 2's done. 2 times 64. 2's done. 8 times 8. 2 times 4. 2 times 4. These are done. You can see why I circle them now, because otherwise they would get lost in here. And again, 2 times 2. 2 more 2's. Circle, 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 circle. There's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8 of them. All right. I'll write them out, I guess, as 8. 1, 2, 3. Okay, and then I'm going to group them. 1, 2, 3, 4 of them. I wondered if I wrote all of them. Okay, so now I've got 2 times 2 is 4, times 2 is 8, times 2 is 16. So I know the square root of 256 is 16. I know my fence, the sides will be 16. Let's go with feet again. And that's how I solve that. You could also do it with factoring. That might take longer, but if you prefer that method, that's fine too. All right, so where do you go from here? You'll see after, or in this lesson, after the video, the visual notes in red. Those summarize the factor tree method I just showed you, and they're printable. They're not as messy as my scribbles. And then you'll see the assignment title. You can click the blue link that says squares and square roots, and it'll take you to the assignment questions. You complete these on loose leaf. You can print them out if you prefer, or you can just read them off your screen. But do complete them on loose leaf, and then you'll have to scan them and hand them in. I'll look at them and get back to you on where to go from there. The GSSD rubric's also posted for you to refer to, and that's how I'll be marking with you, or I'll be marking you. So just make sure that you write down all your steps and you're not just putting answers in there, because I have to be able to see your work. And remember, you can watch this lesson again if you need. So off you go to the assignment.